available energy on planet Earth.
All right.
In order to utilize this energy, we need help from the second most abundant element on Earth, sand. The sand has to be converted to 99.999% pure silicon crystals to use in solar.
All right, so after you have seen the video, it's very clear that the source of the semiconductor material, which is basically silicon where we construct the photovoltaic cell, comes from sand. And the chemical process and high temperature to produce the cell, it's a very sophisticated process. However, the photovoltaic cells and solar energy systems are now available in the market with no any interference from the customers on the process. And the price, of course, reduced a lot, and there are lots of arrangements for the easy or friendly user generators of electricity from the solar system. Okay, and I will continue explaining how the direct current, which is the DC current, as I mentioned earlier, the photovoltaic or the solar cell is a DC current source. It's a current source, so direct current. And it's a direct conversion of light into electricity, where after the photons from the light hit the surface of that semiconductor, which is the silicon, in a special arrangements called p-n junction, then that light will be converted in atomic level to electricity, and electrons will flow in the circuit. PV effect causes semiconducting materials to absorb photons of light and release electrons. PV effect was first noted by the French physicist, his name is Edmund Becquerel in 1839. And the VI characteristics of the PV cell is usually explained or given or even printed on the underneath the panel. And the IV curve is one of the most important properties of PV module or array. Module means the arrangements of the series and parallel or series parallel connections of those cells forming, as you can see here in the drawing, forming the PV panel. Why do we connect those cells in series and parallel? To receive the desired voltage and current. Voltage and current. And here we have to mention that only V open circuit is the notation or the abbreviation we need to use for the voltage here. It's open circuit voltage. We cannot say open circuit current because current doesn't flow in the open circuit or in the air or space. So it needs to be short-circuited. So that's why we call I short circuit. So this VI characteristics is the V open circuit and I short circuit characteristics. Here in this figure, we can easily see that the voltage is affected by temperature and the current is affected by the light or by the irradiance. You can see with me here, the voltage will decrease when the temperature increases. So in hot areas, the photovoltaic system is not so efficient in hot areas, while the current will remain the same almost the same when the temperature increase or decrease. The current is only affected by the light. By the light means by the irradiance, which is measured by watt per meter square. So you can see here that the current, the short circuit current, will be higher when the light is more, when the short circuit current or any current, when the light intensity is increased, when the irradiant is increased. All right, so understanding the VI characteristics of any PV panel, it will give you a very clear idea about which panel you need to buy, which panel is good for your application. And of course, later you can see how to calculate the efficiency, how to measure the efficiency of the panel by multiplying the voltage
Wow.
to get the proper efficiency, the efficiency of your panel, because efficiency is equals output over input. Efficiency equals output over input. And your output is the voltage times current. V times I is your output, which is watt. And your input is the irradiance, the sunlight multiplied by the area of your panel. In this way, you can calculate the efficiency of the panel. I wish you get an idea about PV panels, and see you next time.